Yo, focus up here, please. It's a little hard to do. All right, so what do we do with this? What's our strategy if we want to simplify this? Okay, good, perfect. So first thing we want to do, we want to simplify everything we can inside the parentheses, right? So let's do that. So we're going to do this. We're going to inside the parentheses. Let's just break this into parts. Let's start with the numbers. Does 7 over 2 reduce? No. So what we're going to do then is I've got my fraction bar there, and I'm just going to put pieces where they go. Okay, so Kenzie, next, let's focus on the y's. How about?
It'll be y 5.
Where?
On the bottom.
On the bottom. Good. And how come? What's your thinking?
Because you always go to the bigger number.
Okay, so y has a bigger exponent on the bottom, so we go to the bottom, and then we subtract the top exponent from the bottom on the bottom. So we get y to the 5th. Good. Okay, what about the z's? Maisie, what about the z's? Where do those go?
Also on the bottom.
Bottom.
And it'd be Z3.
Good. Okay. So we took care of simplifying everything in the parentheses. Now what's left to do? Jasmine, what do we do now? Distribute. Good. Okay, so when we distribute the power of 2 to all the parts, and there's 4 things we're distributing to, right? What are we going to get on the top? 49. How about on the bottom?
4.
What power of y?
10.
Good. How come 10th? You're right.
Because it's property to a property.
Oh,
right?
Power to a power.
Power to a
Good.
power.
Power to a power, you multiply the exponent. So we're taking y to the 5th to the 2nd, right? So y to the 10th. Lariah, what about the z's? What are you going to get for that? Z cubed squared. What are we going to get for that one? 6. Good. And that's our answer. Okay? Make sense? Yeah. No big. Okay? How about this one? Okay, take a second, get out your notebooks, and just see if you can plow through that one real quick while I take a roll, and then we'll talk about it very briefly. Notebooks out. Oops. Oh, darn it. Okay. I love dogs. Okay. All right. Oh. Okay, so what do we get here? What are we going to get? So if we... Okay, so the numbers. 1 over 2. Good. So we're going to get 13 over 26 becomes 1 over 2. Now, what about this part? Let's look at the x's. Here's something sort of important. How are we going to deal with the x's? What do you think?
Since they're negative, so if negative and negative cancel out, so it'd be 7. And negative 7 plus 3, so then it'd be negative 4.
Okay, so there's a couple things we could do. We could switch the powers, right? Because we know That's one strategy. Let's look at it. There's another one that's going to be a little shorter, but you can take your pick. So one thing we could do, let's just focus on the x's only. X to the negative 3 on top is equivalent to what?
Positive.
X to the positive 3 on the bottom. And x to the negative 7 on the bottom is equivalent to x to the 7 on the top. And so now we can see an answer, right? So now that's equal to, where does the x go? Top to the 7 minus 3, right? Which is 4. Okay. There's another way we could do it. That's fine. That's the answer. It's x to the 4th on the top, but we didn't even really need to do that. We could just think about the exponents the way they are and use the same power rule. Justin, what's a greater number, negative 3 or negative 7?
Negative 3.
Negative 3 because it's further to the right on the number line, correct? Okay, so we could just say, because negative 3 is bigger than negative 7, the x is going to stay on the top, and we're going to subtract negative 7 from negative 3, right? What's negative 3 minus negative 7? 4. Either way, we're going to get x to the 4th, aren't we? And what about the y's? Okay, just going to be y to the 1 on the top. We don't even write the 1, do we? It's there, but we don't write it. So what's our final answer then? I'll put it for now, but we're gonna rewrite this anyway. Do I need that 1? No.
So it's x to the 4th.
X to the 4th.
Y.
Over 2. That's it. Okay? Good? All right, one more of those. That guy.
I don't like that.
Ooh, it looks pretty ugly, but it's not that bad. Not that bad.
Yeah, I know what the W is.
Okay, good. So one thing we want to do is let's work inside the parentheses again. And let's just add up what we can. So the 10 over the 7 doesn't reduce, right?
No.
What about the W's though?
I don't get it.
So what am I going to get, Tyler, when I multiply all those powers together?
2.
Yeah, W to the 2. You see how we get that? If I get W to the 4 plus 5 is 9 plus negative 7, right? So W squared. What about the X's? Okay, so on the bottom I get an x to the negative 8, and then the y to the 9th just stays the same. Good. Okay, so there's one more thing we could, well, let's talk about this. What are my options here?
Let's do with that x.
Okay, maybe move the x to the top, because it's negative,
Or distribute negative.
or distribute the negative 2. Which one do we probably want to do? What do you think?
Distribute.
Let's do the x. Here's why. Because distributing, now let's just think ahead here for a second, and what kind of situation are we getting ourselves into? If I distribute the negative 2, I'm going to have to move everything individually, right? That's a lot of steps. Right, everybody with me? Okay, so let's not do that. Let's go ahead and just take this negative 8 and move it up there and make it an x to the positive 8. Okay, so I can get rid of this guy. Oh, what I just did. So let's get rid of this guy from the bottom then. We moved it up to the top and made it a positive exponent, right? Okay, now instead of distributing the negative 2, what we say is a great trick with fractions. If I have a fraction to a negative exponent, what do? Okay, I flip them, but if I flip both parts of the fraction, I'm really just taking the reciprocal, right? So I can write it as the reciprocal to the positive power. So we'll write this whole thing then as the reciprocal of this. So on the top, we're now going to get a 7 y to the 9th, and on the bottom, we'll get 10 w squared x to the 8th to the positive 2. And now I can distribute. Make sense?
Yeah.
Okay, so then the last step, what am I going to get when I distribute? How about the 7? 49. How about the y?
81.
18, right? I'm not squaring, I'm multiplying the exponents. And on the bottom, to the 4th,
8, 16.
to the 16. Good, I heard it. Make sense? That's our answer. Can't do anything else with that. Okay, so then there's a couple like this on the last assignment. It looks complicated, but it's not. It's not. Think what they're asking here. They just want the volume. How do we calculate from geometry? How do we calculate the volume of a rectangular prism?
Times length times width times height.
Yeah. So here's the length, there's the height, and there's the width. I just multiply those together, and I'm done. right? Using properties of exponents, that's no big deal. Okay, so here's another one. How about this guy? The length of a rectangular prism is 7 times its width, the height is 3 times its width, and the width of the prism is x to the 6th. Essentially the same problem, isn't it?
Yeah.
What are the dimensions? If the width is x to the 6th, what's the length going to be? If the length says it's 7 times its width.
X 42.
If I multiply,
Wait.
are you sure?
6 times 7.
How's that going to work?
X to the 13.
No. Now that's what it would be. Now think how we'd get that. I see why you're coming up with that, but that would be by doing this. That would be taking x to the 6th to the 7th. Then that statement would have to be the length is the width taken to the 7th power. That would be,
Wouldn't you just
7x.
add 7 to the 6?
no, because that's what I would do if I were taking x to the 6th to the 7th power. What am I really doing? It says the length of the rectangular prism is 7 times its width. What's the width?
Oh, you times the whole equation.
Yeah. So the length is just going to be whatever the width is. It's just 7x to the 6th. That's it. Right? Does that make sense?
Yeah.
That says 7 times the width, doesn't it? And the height, it tells us, is 3 times the width. So what's the height going to be?
3x.
3x to the 6th. And then I'm just going to take the product of those three, right? You can do that. Okay? Last one. I'll let you work on this. This guy. Okay, this one's a little more challenging. I'll make this one worth a little less than the other ones because it's kind of a challenge one. But I want everybody else to try it. I'll make it worth a little less, but you got to give it your best shot. So it says this time they give us the volume of this cube, right? It's that. They're telling us it's that. They want us to find whatever the missing dimension is. And it's probably going to be, the missing dimension is likely going to be in terms of x's and y's and things like that, in terms of variables. Well, they give us 2 of the dimensions, right? And the one that we're trying to find is this missing one. Let's just call it, how about D, capital D, for dimension. And we're trying to solve for D algebraically, right? How could we do that? What do you think?
I don't know. There's no, that it would be a z variable.
It's going to have some z's in it. It might have some other things in it too. Okay, how are we going to get this though? If we want to solve for that missing dimension, it means think what that says mathematically. We're going to ask the math gods the question by setting up an equation, which they'll answer through algebra, right? We got to come up with an equation to solve that. What do you think?
Wouldn't it be those 2 dimensions divided by that whole equation?
Okay, so now we're on to something. The equation we could set up would be that dimension, right? So 4 over v to the 4th times 3 over x to the 6th times d, which we don't know yet, is equal to the volume, right? Then all I've got to do is just get the d by itself. Now, I'm going to let you do that, but let's think about the kinds of things we might be doing. Let's just say hypothetically we got a different equation here. Let's say we've got something like 2x squared over y times d equals 4x cubed, y cubed, z cubed. How would I isolate d?
You would divide 2x to the 2nd.
Yeah, I've got to, right now, d is being multiplied by this fraction. How do I undo multiplying by a fraction?
You have to multiply.
Okay, divide by the fraction, which is the same as multiplying by
Reciprocal.
the reciprocal. Yeah. So I could multiply both sides by y over 2x squared. I don't have room over here, but you get the idea. Times y over 2x squared. And then that's going to cancel everything on this side, and whatever I get on the other side is my answer, right? You see? Okay? That's all I'm going to help you with on that one. I think you can get it from there. Okay, questions? We good? Okay. Last day to work on this. Tomorrow we'll do new stuff. We got a little time though. Let's go down to 205.